Hello friends, tell me where you are right now. Home? Office? Cafe? Club? Out in the open in some street? Where? No matter where you are, that place has an address, right? Maybe it has a plot number, a street name, a township name, and also a zip code or what you may call the pin code. Agreed? So, if I wish to visit you or exchange letters with you in the real world, I need to know your address. Now friends, in case from my internet device, say my mobile phone, want to send some information to your laptop. In that case, how internet will know that I want to reach to you or in return you want to reach to me? There is a similar kind of address as required in physical world is also required in internet space. This address is called Internet Protocol Address or simply IP address. An IP address allows your device to send and receive information with other devices in a network. There are two kinds of IP addresses, IP version 4 or IPv4 and IP version 6 or IPv6. An IP version 4 or IPv4 address is made up of 32 bits. It means that this IP address is unique in my device and also unique in your device. So my data should not reach to someone or other unwanted device. Under IPv4, only 4.2 billion unique IP addresses can be assigned and used. And at present, IPv4 addresses are nearly exhausted in the world. IPv6 is in 128-bit address instead of 32-bit of IPv4. In ever-increasing internet users and internet devices, the solution is to switch over IPv6. Since an IPv6 address is a combination of 128 bits, we can have virtually unlimited unique IP addresses under this system. IPv6 is much faster and several times more secure than IPv4. It secures internet usage and removes stopgap arrangements. IPv6 is the key to the making of such smart cities and smart buildings. So, anyone who desires high security, scalability, connectivity should immediately opt for IPv6. Friends, let us now discuss why we need our own IP pool. To avoid any dependency on any service provider and to run an independent network setup, we should have our own IP pools and autonomous system number. Your own IP pool helps to differentiate your network from other networks and to exchange routing information with them. With your own IP pools or autonomous system number, as an entity, you can have access to better transit rates and peering services. You may change your service provider as per your expected service level agreement, that is SLA. NIXI, under the aegis of Ministry of Electronics and Information Technology, Government of India, has taken major strides in the path of adoption of IPv6. NIXI is a sole Indian agency to delegate and manage IP addresses in India. Are you ready to join digital economy? Let us learn how to get your own IP pool. Step 1. Open URL https://www.irinn.in. Step 2. Click on Apply Now on Homepage. Step 3. Accept the agreement and submit the online form.
What is IPv6 and how it is going to work? First of all, comparison why we are moving for IPv6 if we are already using with IPv4, right? So development of IPv version 6 is a process that been underway since 1993, fearing that the world may exhaust the IPv4 address space. Developer of the next generation protocol, IPv6 not only remediate or we can say provide the address shortage issue, but it also enhanced the IP address process. The process of developing a transaction plan will also require justification for adopting a new IP service, which is IPv6. So to understand this, we also need to discuss what are the issues we are facing with IPv4. That's why we are moving with the IPv6. So IPv4 designed in a time with a different network requirements, originally a military protocol, provided resilient communication and independent path selections, while becoming a standard for a communication mechanism where were added later to support evaluation of the network. So of course, if we are using IPv4 from the long decades, so of course we also have some features, right? So we have a security, but we are dependent on IPsec protocol suite to secure our IPv4, but that is only for a layer 3, not up to the application layer. For device roaming also, we have a mobile IP solutions. We also have a quality of service so that we can prioritize the traffic for voice and others. And what the shortage problem we are facing, because IP address 4 is rapidly used, because earlier we are thinking like maybe we are going to use IPv4 address for just servers in a company, but it's not happened that way. So what happened, the people everywhere we are going with IP address uses. We have a public sites, social networks, our websites, surveillance cameras, everywhere. Not only the company standard, even in the home users, we are consuming IPs very, very quickly. That's why we have a solution of IPv6, IPv4 shortage, like we are doing with like DSCP. We can provide IP address netting, by which we can translate multiple IPv4 address to the single IPv4 address. We also use subnetting, VLSM, to provide again the better uses of IPv4, right? But that all solution which we discuss, is a short-term solution, and it is not compatible with all kind of application also, especially where we are moving with the next generation device and IoT solutions, Internet of Things, right? So when the concept of TCP/IP was originally developed by Windsurf and Robin Kahn under the auspices of the Defense Advanced Research Project Agency, we call DARPA, a US Department of Defense agency, modern day network requirements such as security, quality of service, device auto configuration, privacy, and high level of network device diversity did not necessarily apply. The DARPA, the known only as ARPA network, was expected to be closed network that is limited to few thousand of users, mostly scientists from the government and academia. Segmentation and improved routing. Theoretically, limit of 32-bit address space is approximately 4.3 billion devices, but practical limit of 32-bit address space is approx 250 million devices only. Neither of these can accommodate one IP address per person, right? So IPv4 will not complete our requirement or not able to work with our solution, what we required for. If we take a closer look how the IPv4 consumption happened like quickly till 2010, this is the short history of IPv4, how it is added from 1969 until 2009, right? And we already move with IPv6 as well in that history, right? Now the next generation IP. So in the next generation IP, the process included collection requirement for various industry cables, wireless, electric power utilities, military, corporate networks, service provider, and others. A call for proposal RFC 1550 was issued, and several proposals were studied. Of all the protocol, 3 warranted more extensive analysis and attention. Common architecture for next generation IP. We have Simple Internet Protocol Plus and TCP User Datagram UDP, bigger addressing Tuba, and the recommended proposal submitted by Internet Engineering Task Force with the RFC of 1752 was a SIP. With a larger address space, the main author of the SIP was Steve Deering. A working group was established, and the first specification came in late 1995, RFC 1883. The major milestone of IPv6 as followed. 1996, we testbed the IPv6 called the 6-bone was started over the internet. At this time, Cisco already had support for IPv6 on a limited number of Cisco hardware platforms. In 1997, a first attempt was made for a provider-based address format. Registrars, or we can say registries, started to assign IPv6 prefix to ISPs. Then in 1999, and the IPv6 forum was founded, and in 2000, many vendors began to bundle IPv6 into their mainstream product lines. In 2002, Cisco introduced IPv6 generic availability in Cisco iOS software version release 12.21t. Now, if we do the comparison between IPv4 and IPv6, we can have a look here. Like IPv4 has a 32-bit address that we already know, and IPv6 we have 128-bit address scheme. It supports manual and DHCP address configuration. It supports auto and renumbering address configuration. In IPv4, end-to-end connection integrity is unachievable, so we cannot achieve it. In IPv6, end-to-end connection integrity is achievable. It can generate approx 4.29 into 10 power 9 address space, where in IPv6 we can go for quite larger than think. It can produce 3.4 multiply 10 power 38 address space. The security feature is dependent on the application, but in IPv6 we have inbuilt security feature in IPv6 protocol. Address representation in a decimal. In IPv6 we have address representation in a hexadecimal value. The fragmentation performed by sender and forwarding routers. In IPv6, fragmentation performed only by the sender. In IPv4, the packet flow identification is not available, but in IPv6, packet flow identification are available, and we can use the flow label field in the header. In IPv4, the checksum is available, but in IPv6 it's not required. It has a broadcast message transmission scheme, where in IPv6 we have a multicast and anycast message transmission scheme is available. In IPv4, encryption authentication facility not provided directly as a default, but in IPv6 it's a default provided. In IPv4 we have a header size of 2260 bytes as per used. In IPv6 we have a fixed 40 byte. So that is just a differentiation for IPv4 and IPv6. So what is IPv6? So IPv6, we can say Internet Protocol version 6 is a network layer protocol that allow communication to take place over the network. IPv6 was designed by the Internet Engineering Task Force in December 1998 with the purpose of superseding the IPv4 due to the exponentially global Internet users. So of course, when we already know that we are lacking with IPv4 address very quickly, so that's why we move with the IPv6. But it's not only provide the big or larger address space, but they have many inbuilt features which support for next generation IoT device as well. Why is IPv6 required? Like I said, the primary function for IPv6 to allow more unique TCP/IP address identifiers to be created now that we have run out of 4.3 billion created with IPv4. This is one of the main reasons why IPv6 such as important innovation for Internet of Things devices, interconnected products are becoming increasingly popular, and while IPv4 address could not meet the demand of IoT products. IPv6 gives IoT products as a platform to operate for very long time. There are dozens of reasons why IPv6 is superior to IPv4 and why this new Internet protocol is important for companies to understand, but we are zeroing in the IPv6 for IoTs. Let's take a look at 3 of distinct advantages it offer. Of course, so because we have to move with the new technology IPv6, we need to understand how it behaves, how it works. Then only we can understand what are the security measures we have, what are the threats is available here, so that accordingly we can provide the secure environment. So first consideration is a security, then scalability and reachability. Now if we talk about address space, even it is very difficult to pronounce it. So IPv6 has a 128-bit address and has much more larger address space than a 32-bit IPv4, which offer as bit more than 4 billion addresses. Keep in mind every additional bit double the number of IP addresses. So we can go from 4 billion to 8 billion, 163 to 464 etc. keep doubling until you reach 128-bit. So mostly maybe you can laugh, like mostly we heard like 1000, million, billion and hardly the trillion. But here we have a very big range. So 1000, million, billion, trillion, quadrillion, quintillion, sextillion, septillion, octillion, nontrillion and decillion and undecillion. So it's a huge range which we can use for long time. That's mind-blogging. This gives us enough IP address for networks on Earth, the Moon, Mars and rest of the universe. So quite interesting, right? IPv6 improvement over IPv4 features and benefits. So like we already know few things which we discussed with the IPv4 and IPv6. Now you have a clear picture about that. So no more NAT. Of course, like in IPv4 we are using a NAT, and we know that without NAT we cannot utilize, we cannot work with IP shortage. So if we have, let's say, 1,000 machine in a private network, we require to use a NAT so that we can get the public access without using a multiple public addresses. So we can facilitate the limitation of what we can say as a public IPs, right? And we already know that we are already in the shortage. But in IPv6 we have a huge address space, so we are not going to use any NAT options. We also have auto configuration, some device, IoT device, small device, industrial standards, IoT device. We can get IP address automatically without doing any configuration that is we required for. No more private IP address collision. So because we can directly work with IPv6, better multicast routing, simple header formats. So if you look for IPv4 format, that is bit difficult to understand, and its flow is very lengthy. But here it's a simple format to understand the flow. Simplified, more efficient routing that we will discuss later through quality of service, also called as a flow labeling. Built-in authentication and privacy, support, flexible option and extension, easy administrator, no more DSCP requirement. IPv4 use a 32-bit address for the internet addresses. That means it can provide support up to 2 power 32 IP address, in total around 4.229 billion. That may seem like lot, but all 429 billion IP address have not been assigned, leading to address shortage issue we face today. And IPv6, as we know, roughly it is 2 power 128 bit. It is 4 time multiplier of the addresses we have in IPv4. IPv6 not only big address space, but it also offer some unique feature. No broadcast traffic. So earlier we are in IPv4 we are communicating on the basis of a broadcast traffic, but we don't have a concept of the broadcast. We only have a multicast and anycast. Stateless configuration. So in IPv6 we can assign IP address directly without using a DHCP server. Address renumbering, we can manually decide what kind of IP address, what kind of subnet range we want to provide as a stateless configuration. We can go for mobility, use the same IP address even we are changing from the different location. No NAT pat we required. We have inbuilt IPsec, improved header and migration tools. If we are using IPv4 address already in our network and other link we want to connect with IPv6, we have to go with the migration tools. So here you can see the IPv6 address connected with worldwide, all kind of device like your mobile, your laptop, your cameras, your surveillance devices, websites.
I have put all of the transition mechanisms in one place here. So the majorly 3 categories are there: dual stack, tunneling, translation. So these are the 3 possible migration techniques that are there in place in the production networks. So we will be understanding that why one is better over another, and what is the accepted, widely accepted transition mechanism for enterprise. So that's what we'll be looking in the last. So if we talk about the dual stack, so it's possible, it's widely accepted. It's because it is possible with all of the hosts, whether it is the end host like Microsoft based machines, Linux based operating systems, so or any other mobile devices, all of them are supporting now the IPv6. So it's one of the mechanisms. In tunneling we have got the few methods here: manual, semi-automatic, automatic and based on the VPN. The network address translation and protocol translation, it's a lot similar to what we have been working with, the network address translation of IPv4, but the difference is here in this the IPv6 address is translated into IPv4 address and vice versa. It's possible both ways. So in IP version 4 we used to translate private local addresses to public IPv4 addresses, right? So that was the translation. So we call that as the global addresses, right? So that's what we were doing with IPv4, but in NATPT the v6 address is translated into v4 and other way around. That the dual stack is the most common IPv6 transition approach. We also learned that the satisfying the technical and economic requirements for your IPv6 transition effort that requires that you assess the use of a number of choices available. There are choices available, as we have seen, the tunneling. In tunneling we have got many. We have got static tunnels, GRE based static tunnels, and we also have got the automatic tunnels like 624, and successor to 624 is the 6RD, rapid deployment. So you have to look on all those mechanisms and then assess this situation and what exactly your organization requirement is. NATPT is the translation mechanism that allows IPv4 only and IPv6 only nodes to exchange traffic, but that's used as a last resort because of having many drawbacks with it. So it's almost deprecated. Understanding the advantages and disadvantages of various transition mechanisms will for sure help you develop successful transition plans for your company. And if you want to get your own public IP address, then you can visit www.nixi.in, or you can send your query at helpdesk@iron.in. You can also contact at 011-4820-2030 or 05. I hope this has been informative for you.